Hi, this is Mrs. Pullen for AP Statistics Chapter 6 review, and we're on example 11. The systolic pressure among 20 to 30-year-olds is roughly normal. If 10% have levels above 86 millimeters per mercury and 20% have levels below 69 millimeters of mercury, what is the mean of the distribution? So we have two clues in the problem. We're looking for the mean, and we're told that the distribution is roughly normal. And so that's a clue that we're going to end up finding the z-scores for the 69 and 86 blood pressures, and then using the z-score formula. Okay, so our mu is going to be the same for both distributions. One distribution, we're given that the blood pressure is 86, and that represents the top 10%. That means that 86 is in the 90th percentile. And likewise, we're told that a value of 69 is in the 20 percentile, because we're looking at the amount below. And so what we're going to do is you're going to use the inverse norm for both. So we'll do the one for 86 first. And so you're going to enter the percentile. The mean of the z-score is 1 and the standard deviation is 1. When you enter that into the calculator, you get 1.28. And now we're going to find the z-score for 69. And that's 0.2, the mean of 0 and the standard deviation of 1. And that gives you negative 0.84. So the z-score formula, which I'll write above here, is the z-score is equal to the data value minus the mean over the standard deviation. So I can set up two equations. The first is 1.28 is equal to the data value of 86 minus the mean over the standard deviation. That's equation 1. And equation 2 is based on the other z-score of negative 0.84, the data value of 69. The mean is what we're solving for, and we're also going to be solving for the standard deviation. If I cross multiply, the equations become linear. And so I set up the systems. Now you can solve these systems either algebraically or you can solve them through the calculator. I'll do both. So the first thing I'm going to do is I'm going to take that second equation and multiply it by a negative 1. In essence, I'm changing the sign. This is if I was doing it by hand. And when I do that, I get 2 carry the 1, 11 carry the 1, 212. Sigma is equal to 17, positive 17. And then if I divide both sides by 2.12, let's go to the calculator. So let me get into a calculator page. So 17 divided by, let me just double check, 2.12, I get 8.02. Again, this is if I do it by hand. And then I would have to get mu, so it would be 1.28 times 8.02 is equal to 86 minus mu. and I'm going to subtract 86 from it and divide by a -1, and that gets me the mu, the mean, of 75.7. Just to note that my original answer key was incorrect, so we corrected it during the period. Okay, now that's if I were solving by hand, but what I could have done is enter the system into the equation, into the calculator to solve, and I'm going to show you that as well, just in case if anybody's interested. So when you do that, you would do menu, algebra, solve systems of linear equations. We have two equations, two unknowns. I'm going to treat my y as the standard deviation equals, notice I'm just typing the equation, 86 minus, and I'm going to call mu x. And then for the second equation, it was -0.84 y is equal to 69 minus x. And obviously that's much faster. My x was the mean of 75.7 and my standard deviation was 8.02. I hope this video helped.